All right, so far, when you guys have had to graph in the coordinate plane, we've always graphed rectangular coordinates, right? And what I call rectangular, like if I give you the point 3, 4, that's right here, give or take, yeah? All right, and so the 3 and then the 4 is describing that I'm going 3 to the right and 4 up and down, kind of making a rectangle, yeah? Hence rectangular, okay? So today we're going to introduce polar coordinates. And basically, I could just as easily describe this exact same point as a radius and an angle. Okay? So it's the same point, right? It's just sometimes it's easier to describe things in terms of these polar coordinates instead of the rectangular ones, specifically because rectangular ones assume flatness, right? When you think about, for instance, latitude, longitude, those are all angles for a reason, right? Because the flatness is not actually true. Okay, so describing where things are in a polar way can be useful. Okay. All right, so when we do polar coordinates, the way the coordinates are written is we have the radius first and then the angle second. Okay? So we're just going to graph a couple of points here. So this first one, this is basically saying my radius is equal to 3 on the angle pi over 2. So if I've traveled pi over 2, I'm on basically what is equivalent to the y-axis, with a radius of 3 would put me right here. That is my point A. All right, positive angles travel in the counterclockwise to get direction. How did I get together from direction? I don't know. And likewise, negative angles travel in the clockwise direction, but that shouldn't feel new to you guys, right? Okay. All right, so the point 2 negative pi over 4, again, radius is equal to 2. So like you'll see a lot of times with polar graphs, you'll be giving these polar graphs kind of like with these concentric circles to help you envision where that radius is. So 2 negative pi over 4 would be here. Everybody good? Now, I'm going to add one more point for us to graph because I didn't do a good job writing this. Let's do negative 2 pi over 6. Okay, so are you guys with me? Pi over 6 is right about here. So, but negative 2 pi over 6 would put me, a negative radius just puts me in the other direction, on the other side of the origin. Is everybody good? All right, so y'all, if I asked you what are the coordinates of this point C, what would you tell me? 4 negative pi over 3, great. Or 4 5 pi over 3. Or negative 4 2 pi over 3. All of those would get you to this location. I don't. I'm pretty good. I can figure it out. I mean, I would say don't be a jerk that's too far away from my answer key. My answer key usually does, like, I'll usually think it through for, like, the positive, the negative, and I don't normally think through the negative radius. Or I don't put it down because I assume that you guys will not put it down. But, like, I'm pretty smart. I can figure it out. Everybody good? So, one of the things we ought to be able to do is convert back and forth between polar and rectangular coordinates. Okay, so the nice thing is, like this picture, how often have you guys seen this picture starting, I don't know, maybe even Algebra 2, a little bit, but you've seen a picture like this one, yeah? And if I gave you this picture, we can kind of see the radius, we can see the angle, we have X, Y, and R, okay? So if I said, if I know X and Y, I can find theta through tangent, right? And I can find the radius because it's a right triangle, right? So there you go. If I know X and Y, tangent and the Pythagorean theorem get me where I need to go. If I know R and theta, well, I can still say, all right, well, what is X? Well, I know that cosine of theta is equal to X over R, right? Like I can write that equation. So if you can draw the picture, you can get to any single one of these, okay? Now, if you guys eventually get to, like these, you will probably get memorized pretty darn quickly. In fact, you maybe have already been exposed to them a little bit with physics. I don't know. Okay, that sine goes with vertical and cosine goes with horizontal. Should be something that kind of makes some sense. Okay, so so I'm going to show you the work and I'm going to draw the picture every time. I am not expecting that. Like if you can get to this, you don't need to draw the picture for me. I'm doing the picture to help you see where everything's coming from. Is everybody okay? All right, so go from these polar to rectangular. So this one in particular, radius of 2, angle of pi. Angle of pi puts me here, yeah? With a radius of 2. What are the coordinates of that point? In rectangular, in terms of x's and y's. -2, 0, I'm done. If I'm using the would be x equals 2 cosine theta, so 2 cosine pi. Y equals 2 sine of pi, which is, again, -2 and 0, okay? All right, if I draw this picture, here's what I would have. This is pi over 6, and this is the square root of 3. So again, if I'm using my picture to help me see it, I might say the sine of pi over 6 equals y over the square root of 3. What's the sine of pi over 6? Everybody good? And then so y is equal to root 3 over 2. Cosine of pi over 6 equals y over the square root of 3. Square root 3 over 2 equals y over the square root of 3. Yeah, thank you. And I get x equals 3 over 2. Are we getting the basic premise here? All right. Right, so let's look at the following. Okay, so now we're going from rectangular to polar. So negative 1, 1 would be right here. If I'm looking at my picture kind of looks like this, yeah? Sometimes I make that negative just to make things make sense to me. All right, so what angle is that? That angle's 3 pi over 4. Let's say I don't know that. I know that the tangent of my angle is equal to 1 over negative 1. Now, we have to be a little bit careful here. This can help me figure out, like if I do the tangent inverse of this, I get pi over negative, well, if I do tangent inverse here, I'm going to get negative pi over 4. Is everybody with me? Because it's not going to give me all the angles. We talked about this really early in the school year of like, when you do tangent inverse in your calculator, it's going to give you an angle between negative pi and positive pi only. Okay, because it can't give you all the different ones because there's, infinite. Okay, so you're going to have to think through what quadrant is my point in, but it can at least help us see that reference angle, this one, is a pi over 4 angle. Is everybody with me? Okay, so theta, if I said theta was negative pi over 4, that's fine. Okay, but then when we go to do our radius, we're going to have to think that through. Okay. What is my radius, by the way? I know I would do 1 squared plus 1 squared equals my radius squared, yeah? By the Pythagorean theorem. Is that very good? So my radius is equal to the square root of 2. So if you told me the point negative 1, 1 was 3 pi over 4 square root 2, just great, wonderful. If you did that tangent inverse and you said, hey, my angle's negative pi over 4, negative pi over 4 is down here. So you would need to make your radius negative to get it up into that second quadrant. Do you guys see what I'm saying here? So both of these would be sufficient answers in my head. Okay? But it's not just a like, did I do it backwards?
Radius.
Oh. Oh, Larry's, I have it wrong on both of these. But is everyone understanding what I'm saying? Like, you just have to make sure you're thinking through which quadrant am I in? Is my angle currently going to get me there? And if not, I need to make my radius negative to reflect over into it. Zero 2 is this point right here. When it's on the axes, I think it's easier to just think through what is that angle? What is that radius? The radius is 2, the angle is pi over 2, and call it a day. All right. Now, we have polar equations just like we have rectangular equations. So if I asked you to graph a line in the rectangular form, you know a line has the form y equals mx plus b, and it's y written as a function of x. In these, we write r as a function of theta, okay? Now, when my equation is r equals 2, and I'm not defining theta in any way, what I basically am drawing is a picture of all the points where the radius is equal to 2. which is basically our definition of a circle because the radius is always the same. So this is the point. So this would be like 2, 0, and then the next one might be 2 pi over 2, and then the next one might be 2 pi as we kind of count those through these. And then if I go all the way around and keep going around, I'm just going to keep ending up with this same circle with a radius of 2. And likewise, if I'm plotting the polar equation theta equals pi over 3, so for instance, that could be 0 pi over 3, 1 pi over 3, 2 pi over 3. Is everybody seeing it? Okay, but they're all going to stay on that pi over 3 line. Negative 1 pi over 3 would just pop down into that third quadrant, and we get a line. Okay, so in rectangular coordinates, like y equals or x equals give us vertical or horizontal lines. In rectangular equations, they give us lines and circles. Always on that same angular line or always on that same radius. So what happens to if it's not just r equals consistent radius, but rather my radius is a function of whatever my angle is, okay? So we're going to plot some points here. So before we do this, we're basically saying that our radius is sine of whatever angle we are at, okay? So can we real quick, and because we're graphing these, we're going to do decimal approximations instead of the exact answers, okay? Can we look through, like, what is the sine of 0? And then the sine of pi over 6 is 1/2. That one's pretty easy. The sine of pi over 3, root 3 over 2, thank you, Blake. 0.866. Sine of pi over 2 is 1. That one's easy. Sine of 2 pi over 3 is also going to be root 3 over 2. Sine of pi is 0. I skipped 5 pi over 6, which would also give me a 1/2, okay? Everybody good? All right, so sine of 0 would be here. Pi over 6 1/2 would be, it's a lot easier. I know the grid doesn't show up as well for you guys as it does. Pi over 3.866 would be roughly here, here. And if I continued to increase my angle, what's going to happen in this case? It's just going to keep going around over the same points, okay? And get basically a circle. Now, I'm assuming some of you have already started playing with this. If you go into your mode on your calculator, in the sense that we had function mode, we had parametric mode. I'm assuming you guys see the one next to that, which is polar. All right. If you go and then let's go, now you'll notice your y equals will be r as a function of theta, okay? So if I just do sine theta and I hit graph, you can see a very, very similar graph. Everybody feeling okay? You guys, how would this graph change if we did cosine theta instead? Let's think it through. If this were cosine theta, when would it equal 1, right? Because that's like, what would that graph look like? It's going to kind of turn on its side. Is everybody good? And so, because it's just at a different place, yeah? How we feeling? Good so far? All right. Next. My radius, let's do this one. All right, so what I'm going to recommend we do is I like to do, it feels really weird because I like to make a table of R and theta, and it feels really weird because when we do rectangular equations, we've got y is in terms of x is my independent variable, and I write it first in my table, and here theta is my independent variable, and I write it second in my table, which feels a little bit weird. Okay, and let's just do our basic four corners, okay? So, mm-hmm. Well, these we don't worry about, actually. It's fine if you wrote those in, but you don't need them for graphing reasons, okay? But we are going to do decimal approximations for the radius to help us with the graphing, okay? So if r is equal to half of theta, what is r when theta equals 0? What's half of 0? 0. All right, my next point. What is half of pi over 2? Pi over 4. Which, you guys, is equal to approximately 0.785. Okay. If theta is pi, my radius would be pi over 2, which is 1.57. If r is 3 pi over 2, my radius is 3 pi over 4, which is 2.35. And then pi, which I'm pretty sure that pi is approximately 3.14. Approximately. How are we feeling, okay? All right, so let's graph that. 0, 0. 0.785 pi over 2. So that would be roughly here. $1.57 pi Hopefully we're getting a picture that looks like this, yeah? All right, so here's my question, y'all. What would happen like as I'm looking at this, it kind of makes sense that it would spiral. Like you guys are seeing the spiral, right? And it makes sense that it would spiral because your radius is getting, as your angle is increasing, your radius keeps getting bigger and bigger and bigger for that reason, right? Because they're increasing together, okay? But we kind of made one of like this cardinal sins of graphing. What would happen if my angle were negative? Right? Because we normally, when we draw XY tables, we don't do 0, 1, 2. We do -2, -1, 0, 1, and 2. Right? We want to think through all possible values for my input variable. Right? Is it possible that I put in -pi/2? And if I plotted -pi/2, my radius would be -pi/4, or another way of saying that would be -0.785. Yeah? Do you guys see what I'm saying there? Okay. And so let's see. So -pi/2 would put me right here. And then +0.785. And then if I did that for every point, so let's see, my next point would be -pi, -pi/2, -1.57. Okay, so now -pi is here with a negative radius of 1.57 puts me right about here. You guys seeing what's happening? So what happens is I actually have two spirals. So my calculator didn't show me that when I graphed it polarly, right? So I'd like to talk through, if we go to the window, you see how we now have an x-min, x-max, y-min, y-max. We also have a theta-min, theta-max. And right now, mine is only graphing for thetas in between 0 and 2 pi. What if I had to do -2 pi to +2 pi? Now I can see both sides of that spiral. How are we feeling? We still doing okay? All right. Lastly, I would like to graph this last one up at the top here for today, and then we'll continue tomorrow from the rest of these, okay? R equals 1 minus 2 sine theta. Certainly, I'm going to go ahead and hit graph so we can get the general form of this. What's going on here? Why does it have the loop? 'Cause we all see the loop, yes? There's a cool loop here. So I think again, 0 pi/2 pi 3 pi/2 2 pi. Okay. So when theta equals 0, my radius is 1 minus 2 times 0. No? So 1. That gives me this point. No. Theta 0. So this point. That pretty good? All right. And then when theta is pi over 2, what's sine of pi over 2? Sine of pi over 2 is 1. So I'm doing 1 minus 2. Yeah. Gives me this point. And sine of pi is 0, so 1. Sine of 3 pi over 2 is negative 3. Wait. Is negative 1. Sine of 3 pi over 2 is negative 1.
Radius is 3.
Right, so 3 pi over 2, 3 is down here. Likewise, 2 pi. Take this one. Okay. And certainly it's hard, it's kind of hard to jump from the current points that we have to this graph, right? Okay. So something that is very, very useful is to think through what we call the poles of the graph. And the poles are where the radius is equal to 0. Okay, so the radius in this case will equal 0 when 1 minus 2 sine theta equals 0, which is when sine theta is equal to 1/2, yeah? So for which values of theta is sine equal to 1/2? Pi over 6. So, which is right in between here, right? So I've got a 0 and a pi over 6 in between here, as we think as we're counting my points, okay? So it goes from here to 0 down to here. And then 5 pi over 6, it hits, again, 5 pi over 6 is in between here. So it's got to hit again, and then it's not as big a stretch to get to that graph. All right, so